So good morning, everyone. I'm Oliver Morton. I'm an editor at The Economist. I'm also a trustee of an NGO that works in the area of solar geoengineering, and I'm here to moderate or possibly immoderate this panel on this fascinating, disturbing, and important technology. I should also say that I have a stinking cold at the moment, but according to recent tests, I am not going to give you all COVID, even if I do cough a bit. So of the various things this panel will give you to worry about, contagion from the chair is not one, but don't worry, there'll be plenty of other stuff. Just before we get underway, if you'd humor me, I'd be very grateful. Could you just find someone near you you don't know and just talk to each other for a minute or so about why you've chosen to come to this particular session? I think it really helps for the audience to have a sense of what you're doing. Why are you here? Okay, thanks very much. And you've now established yourselves as a sort of social group so that we know each other on the panel. We've all known each other for years. It's really nice now that you at least know some of each other. And I think that that will give us a better mood as we go forward. So now a little bit of audience research. Who in the audience has read a novel called Termination Shock by Neal Stephenson? Okay. Who in the audience has read a novel called The Ministry for the Future by Kim Stanley Robinson? Significantly more, and one in common. And who has heard of a small startup called Make Sunsets? Okay, so Make Sunsets is interestingly beating out Termination Shock in terms of public knowledge, which is peculiarly ironic since Termination Shock was what inspired those people in the first place. So, to explain why I asked those questions, those are all instances of the idea of solar geoengineering, by which we mean reflecting away sunlight from the Earth, is instantiated. And to start with Make Sunsets is a sort of like Pico startup, which has launched a few balloons into which it thinks have released a small amount of sulfur dioxide into the stratosphere. Why does this matter? Because in the stratosphere, sulfur dioxide reacts with water vapor to make little particles of sulfuric acid, which are bright and shiny and reflect sunlight away from the Earth. And if you did this with millions of tons rather than a few hundred grams of sulfur dioxide, you would make a real dent in the Earth's climate. You would actually be reflecting away enough sunlight to cool the Earth a little bit. And so, aware of this research, partly because they'd read Neal Stephenson's science fiction novel on the subject, Make Sunsets has proposed that maybe it should be selling cooling credits, the value of which would be set by comparison to the amount of carbon that their cooling was offsetting. Now, as a commercial proposition, that is a non-starter for various reasons, which we may come back to if that's the way our conversation takes us. But the fact that Make Sunsets did this at all sent a kind of shockwave through the community of people who think about solar geoengineering. And the community worries a lot about the implications of the sort of stuff that it studies. And seeing people toying with the idea in practice, even on an incredibly small scale, freaked people out. And this all happened late last year, and after this panel had been picked for South by and after we'd chosen this title. But it's important, I think it underlines why this is the right title to choose. An awful lot of discussions about solar geoengineering talk about, should we do it? What should we do? And that leads to some sort of like performative stuff about what sort of people are we? Well, we're good deliberative people, so we will do this in a good deliberative way. If you put it at one remove and say, what if someone else tries geoengineering, someone else tries to re-engineer the climate, then you get, I think, a clearer, or certainly a different perspective on the issue than if you think about whether we, in some sort of like sense of a global united humanity, and we all know that we are, of course, part of a global united humanity on which has very few differences within or between nations on matters of policy. We would always obviously do the right thing. Good to see what other people would do, because it helps us see, in the words of Rob Burns, to see ourselves as others see us. So those three examples I gave make some sense. If we were to take them at their word, would be doing this as a commercial way of selling the opportunity to cool the planet. In Termination Shock by Neal Stephenson, the geoengineering is being done by a Texan billionaire who wants to slow sea level rise, but also doesn't want to stop running great big truck stops, which is the basis of his business. And in Kim Stanley Robinson's book, Ministry of the Future, the solar geoengineering is done by the Indian government in order to, as a response to a truly horrific extreme heat event with which the book begins. I think you can all agree, just looking at that how you think about solar geoengineering probably does depend to some extent upon both who's doing it and whether they're trustworthy and what it is exactly that they're trying to do, because not all aims are the same. So there are some things that we can take in common. Whoever's doing solar geoengineering, there are some things that always come up. One is that it has different impacts on the planet and politics around the world. Solar geoengineering, so to repeat, nothing more complicated really than reflecting away some sunlight, is not, as it were, an equal and opposite antidote to the sort of warming caused by greenhouse gases. It's a different form of climate change. And it's a form of climate change that responds to and might redress some aspects of the climate change now going on. It's not a stop to climate change. It doesn't make these problems go away. In some ways, it makes them harder, but it might well make harms go away, some harms in some places. And the other big issue that matters, whoever is talking about geoengineering, is what is sometimes called moral hazard or sometimes called mitigation erosion. Which now I come to think of it as a very unpleasing term. But the idea is, if people are doing this, then doesn't that make it less likely that they will commit themselves wholeheartedly to emissions reduction? Now, everyone who works on solar geoengineering will tell you that it is absolutely a supplement to emissions reduction. Emissions reduction is the primary response that we would all wish to see to climate change. And when you talk about what we might do, you can say, oh, well, we certainly wouldn't stop emissions reduction just because we were doing this. When you start thinking about what other people might do, though, I think you have to take that issue slightly more seriously. Well, I think everyone takes it seriously, but you have to really focus on the idea that being able to do this without expecting some degree of mitigation erosion, some degree of less emissions reduction, that seems in some ways quite unlikely. So given sort of like the possibility of geopolitical mayhem and slowed action on climate change, why do people like those on stage even think about this sort of issue? Why do we not sign on with a large group of researchers who are interested in basically stopping discussion of this at any meaningful level in the policy world? Well, the answer is because climate change depends on the cumulative emissions to date at any given time. What the climate is depends on how much cumulative emissions humans have put into the sky. And emissions reduction stops that accumulation, slows the rate at which the cumulative emissions increase, but it doesn't reduce them. And so the climate you have is not amenable to change by emissions reduction. What you're doing with emissions reduction is making sure that the future isn't even worse. There comes a time, and no one knows quite when it is, and some people might argue we're at it, when you want to see if there's anything you can do to decouple the climate from all that history, to deal with the climate harm that is already baked in. I actually heard someone from the nuclear industry in this hall yesterday saying that you can't do that. But solar geoengineering suggests that under some circumstances, some value of U might be able to try to do that. And that's why, in a world where the harms caused by climate change are real and increasing, that's why you need to worry about whether other people will do it or whether you'd like to be part of a group, a nation, a movement that wanted to see it done or to see it at least explored. So that's what we're going to be talking about up here. Everyone on the panel has a background in this stuff, but from different areas. But before we get into agreeing and disagreeing and asking you what you think and answering your questions, first, Kate Rickey from the University of California, San Diego, who's made a terrific career out of studying this issue and some other climate issues, but really a leading solar geoengineering researcher, will talk you through some of the options of both solar and other forms of geoengineering. So, Kate.
Thanks, Oliver. I think we have a little slide to talk about it. Right. So geoengineering itself is a pretty contentious term. Not everyone can agree yet on what it even means. And so I'm going to sort of present an old school definition that is not necessarily what a lot of other people will refer to when they refer to geoengineering these days. So geoengineering generally refers to something that is intentional. Intentional is a key piece of this, to reduce some harms from climate change. And it also has to be large scale enough that the change to the Earth system that you're making can be felt in places other than where you're making them. And so there's two types of geoengineering conventionally that people talk about. The first one is called solar geoengineering or solar radiation modification. And these are the techniques that counteract what's happening with climate change by, instead of taking greenhouse gases out of the atmosphere, by reflecting more sunlight back into space before it can be absorbed by the Earth and warm up the atmosphere, basically. And we've got two sort of types of solar geoengineering that we may touch upon today. The first one's called stratospheric aerosol injection or stratospheric aerosols. And with this technique, the idea is that you would fly airplanes high in the atmosphere, maybe release weather balloons that could get up to the layer of the atmosphere that's above where we live, called the stratosphere. And the stratosphere is sort of special compared to where we live. We live in a convectively unstable area of the atmosphere where things are turning over, we get weather. Particles like aerosols tend to rain out of the troposphere where we live within a few days. In the stratosphere, because it's convectively stable, once you put particles into it, they stay there for a while, a year, 2 years. And so the idea with this is that when you put shiny particles up there, they'll stick around for a while, reflecting that sunlight back into space. So we think of it as sort of a high leverage way to reflect sunlight. The other sort of solar geoengineering that's the big one that's talked about these days is called marine cloud brightening. And the idea here is that there's certain areas over the ocean that the clouds, to an extent, their brightness is limited by the number of little particles that water can form their droplets to make the clouds with. And so with marine cloud brightening in these areas of the ocean where the atmosphere is amenable to it, what you would do is spray things like tiny pieces of salt into the lower atmosphere there. When you put those particles in, you get more cloud droplets than you had before. And when the cloud droplets are smaller, they're more reflective. And so this would be a way to bounce back more solar radiation into space as well. The other piece of this is that when those droplets are smaller, they stay in the atmosphere longer. So it extends the life of these clouds as well. So the other type of geoengineering that people talk about is different types of carbon dioxide removal, which are techniques that draw down CO2 from the atmosphere faster than the Earth's natural carbon cycle does. Now, CDR is really widely spoken about these days. And I would argue that there are types of CDR that don't count as geoengineering, but some types of CDR do. And sort of how I think about this is that certain types of CDR really tinker with an important natural process in the Earth system. And these types of CDR, you would tinker with that process in a way that might have broad consequences and might have really harmful side effects. And so the three technologies or proposals that we're illustrating up here are ocean iron fertilization, which might be sort of like the OG geoengineering. This is the idea that in areas of the ocean where you have a nutrient where phytoplankton growth is limited by the level of nutrients there. You add nutrients to the ocean, you get a phytoplankton bloom. Phytoplankton draw down CO2 from the atmosphere, and if you're lucky enough to get them to sink after that, then it would sequester carbon. That sinking has turned out to be a bit of a problem, but let's move on from that. Artificial upwelling is a similar idea. There's more nutrients in the ocean underneath what we call the thermocline. The top layer of the atmosphere of the ocean mixes a lot. That's where the phytoplankton are already eating a lot of nutrients. If you use these big ocean pipes to bring cold, nutrient-rich waters up to the surface ocean, in theory, you could also cause these blooms. That, again, if you're lucky enough to get them to sink before zooplankton and things eat them up, you could sequester carbon for quite some time, reduce that CO2 in the atmosphere, reduce warming. There's been some difficulties trying to figure out if that sinking problem is the really big one. Finally, there's a technology that's getting a lot of attention these days called ocean alkalinity enhancement. And the idea with this one is that you would add alkaline material to the surface of the ocean. Alkalinity, it reacts with CO2 in the atmosphere. The CO2 would more quickly dissolve in the ocean than it does naturally. It forms carbonate and bicarbonate minerals, which also lock up CO2 for a long time. So these are a number of the geoengineering technologies that have been discussed the most to date.
Thanks very much, Kate. And when we're talking about these discussions, and these discussions have been going on for a while, but for a long time they were a very, very small part of the scientific response to climate change. That changed a bit in the mid-zeros, which was when I became interested in the topic, but that's not why it changed. And one of the things that people have always worried about are the side effects, particularly of solar geoengineering, the climate side effects, in terms of drying out the atmosphere, which you would expect to see to some extent, and changed patterns of warming. Now, and so when people were talking about geoengineering 10, 12 years ago, they would always really stress the fact that there could be really big surprises and unpleasant surprises as a result of the sort of strategies of putting particles in the atmosphere that are being discussed, these stratospheric strategies. Now, it's my impression that the work done with climate modeling to look at this sort of thing has to some extent retired some of those worries. And I wonder what you thought about that, Kate.
About how
the degree to which it is now possible to imagine solar geoengineering that has fewer side effects than people would have feared 10 or 15 years ago.
I think that's right. I mean, almost all research about solar geoengineering to date has been done using models, right? Because we can't, build a million real Earths to try it out and see what happens. And so we use these models of the climate system where we have an atmosphere and an ocean and ice and land, and they all talk to each other. They're these cubes. And I would say around 15 years ago, when research on this topic really started to take off, a lot of people started doing these climate model experiments with the expectation that they would show that when you counteract greenhouse gas change to the climate with a change in solar radiation, that you'd get a lot of harmful side effects in terms of it wouldn't counteract climate change in terms of temperature and precipitation at the regional level. But what climate modeling studies have actually shown is that when you design solar geoengineering in a sort of nice, coordinated, globally diffuse way, that you actually are able to reduce temperature change, reduce precipitation changes even at the regional level. And I think that was actually kind of a surprise to people. And because temperature and precipitation are the kind of things that we then take out of these climate models and use to model what we call impacts like agricultural productivity, water availability, health impacts, in turn, that makes solar geoengineering look like it would work better than people were expecting it to.
But that's very much for the sort of solar geoengineering that you might idealize in an ideal way, think, oh, this would be, if everyone was nice and trying to do it for the best of all possible motives, that kind of solar geoengineering.
Exactly. So if you had one decision maker who is in charge trying to maximize global welfare, which of course isn't actually the way that most decisions work in the world. And so the thing is, the particulars of how you would do solar geoengineering would really matter. So there's infinite different ways you could do it in terms of where, when, how much, how long it lasts. And we've really not explored a lot of the potential space there yet as climate scientists. And in particular, if you think sort of about how geopolitics work, if you start to look at some of these things that have been happening in the news, I think it's actually quite sensible to think that geoengineering wouldn't happen in this sort of globally optimized way. I think it's much more likely that this would happen in a sort of regional way in which different players or agents are trying to target certain impacts and do the amount of geoengineering that they think could be helpful, but they can also get away with. And the physical outcomes of geoengineering under those circumstances would be quite different. Some of the work that we've done in my group has shown that we can actually really effectively reverse a drought in North Africa by cooling down the Indian Ocean. But we cause a drought in sub-Saharan East Africa. I have a PhD student who's now working on how could we mitigate heat waves in Western North America by cooling down the Northeast Pacific. And she finds, we could probably do something like that, but we cause potentially negative side effects to the hydrological cycle in other areas of the world. So basically, the outcomes really depend on how you do this. And regional schemes have been very much underexplored, in my opinion, in the physical climate science.
Great. That's a great basis. I'm now going to introduce the other two members of our panel. Shishi Talati, who has a background in both academia and government, but is now bravely starting up an NGO in this space, the Alliance for Just Deliberation on Solar Geoengineering. Note the word just there. And Peter Frumhoff, who's a lecturer at Harvard and was for some time, when I first met him, the chief scientist of the Union of Concerned Scientists. So before we just do a sort of like freewheeling panel discussion, I asked them to just give you a couple of minutes on what they think the key points that they would like a smart audience at South by Southwest to take away from this. So this is sort of like you're getting your conclusions in early. So Peter, would you like to go?
Sure, thanks, Oliver. I should say that in addition to teaching at Harvard, I'm also at the Whitwell Climate Research Center in Woods Hole, Massachusetts, where I'm the senior science policy advisor. I think my bumper sticker on solar geoengineering is that it's the worst possible way to address climate change that we need to take seriously. And worst possible way for a variety of reasons, including the uncertain impacts with regional dynamics and the kind of geopolitical world in which we live. Doesn't address some of the core drivers of climate change and the impacts, including ocean acidification, but take seriously because, in my view, a scenario of deployment is really plausible as we head into a world that is hurtling past the 1.5 degrees Celsius target of the Paris Climate Agreement, where we're already inarguably seeing dangerous climate impacts across the globe, from the Pakistani floods to the extreme weather we're seeing today, literally in California, and those are going to increase. And you know, as we need to and do take decarbonization seriously, it's still going to be a while before we get to, under the best of circumstances, net zero carbon emissions, at a point at which, as Oliver noted, temperature rise will cease, but temperatures will continue to stay high until we figure out a way to draw that carbon out of the atmosphere at scale. And so something like Kim Stanley Robinson's novel, which I highly recommend to you, Ministry for the Future, envisioning a nation, in this case India, of responding to really excessive heat by deciding that it's impossible to ignore and can only be addressed through response in terms of rapid cooling through solar geoengineering, that kind of deployment is foreseeable. And we need to address that. We need to think about that. We need to understand what those dynamics might look like. We need to take those seriously. And it's important, I think, to recognize that deployment is sometimes called temporary, right? In the notion that under the best of circumstances, kind of a Goldilocks world in which we're rapidly reducing emissions, we would have a peak that we would recognize would be incommensurate with what society can maintain. Maybe we're at 2 degrees, maybe we're at 2.5 degrees, which is where current policies and commitments are bringing us towards, maybe higher if we don't live into those commitments. And that when we initiate solar geoengineering, in order for it to have a temperature effect over a period of time consistent with what we would need in order to bring those temperatures back down through aggressive decarbonization, perhaps carbon dioxide removal. Temporary means, in that best of circumstances, of half a century, maybe a century or more, right? Because if you're half a degree or a degree Celsius above the temperature target that you're seeking to maintain, those temperatures are not going to decline quickly. Only under a really aggressive carbon dioxide removal and reduction in methane emissions, which can have a relatively rapid cooling effect, are we going to see temperatures decline? But that's going to take many decades. So we have to envision, in a multipolar, complicated, geopolitically diverse world, being able to make decisions about levels of solar geoengineering deployment, who gets to decide about that deployment, avoiding what's called termination shock, which is the name of another novel that Oliver noted, which is the rapid warming associated with the abrupt termination of solar geoengineering, bringing us back to the levels of warming consistent with wherever carbon dioxide levels are at that moment. These are really serious risks and uncertainties, and we have to be able to envision what governance of this technology under deployment might conceivably look like. We have no governance structure in place today. none really that's consistent with what this challenge would look like. We need to be very sober about understanding what it would take and could we do this. There are some social science scholars who've argued vociferously that governance is impossible. At least just governance is impossible. I know Suchi can speak to the just dimensions of this more deeply than I. But it's really essential to recognize that we don't have a clue how to do this. We're not set up for this now. And so we need to understand what the risks are. We need to have research in order to better understand those risks under different governance regimes. And we need to take seriously the exploration of what international governance of this technology might look like. I'll stop there.
Thanks, Peter. So as Oliver said, I'm Suchi Talati. I'm starting a new NGO called the Alliance for Just Deliberation on Solar Geoengineering. And the questions that Peter raised have haunted me and have really motivated me to kind of dive deeper into this space and to ask questions around what does justice mean at the intersection of solar geoengineering? And so, a lot of conversations we have about solar geoengineering focus on the outcomes we want, right? And rightly so. These are really important questions around how solar geoengineering will intersect with climate impacts. Questions around what solar geoengineering could or could not do, and even questions around whether or not we should be talking about it. But something I want to highlight here is, is diving deeper into the question of how decisions are made and who gets to participate in those conversations. And really that's kind of the core of how I think about kind of where we are right now, the intersection of solar geoengineering and justice. Climate impacts are going to continue, they're going to worsen, even if we meet our net zero targets. And solar geoengineering is something that could be globally impactful. But climate vulnerable communities and countries are really the people who have the most to gain or lose from knowledge around solar geoengineering and potential research. But right now, discussion, research, and actions even around solar geoengineering are almost entirely taking place in the global north. We're also seeing a lot of actors in these spaces speaking on behalf of the global south to provide rationale for their actions or thoughts or their approaches of thinking about the space. But what we really need right now is an effort to build better and more inclusive approaches to how to build a much more participatory structure around solar geoengineering. We need to do this without bias towards outcome, without trying to kind of influence other people with our perspectives, and to actually give them political power and processes around decision making. I think right now we have a really unique window of time. Solar geoengineering doesn't exist yet. And we have an opportunity to build this in a much different way than we've built other governance, climate, and emerging technology infrastructure. And so I think what's most critical to me is that we don't waste it.
So I really like Peter's framing of geoengineering being the worst response that we need to take seriously. And I want to ask all of you, for sort of like practical ways, in what would a world that took geoengineering seriously, how would that look different? How would it look different in terms of national politics, Peter, or in terms of what the scientific community is doing, or in terms of what the international community is doing? And what are the things, another way to see this, if you want to be more competitive, is what is the evidence in the UNFCCC or Congress or the national academies? What's the evidence of not taking this seriously?
Well, I'll offer a couple of comments.
Sure.
Maybe we can just open up for conversation. Look, I think taking it seriously means, to build off of what Kate said about moving beyond optimization models, we need to step beyond the kind of Goldilocks view of if we did everything just right, what would that look like in terms of the science, and begin to explore with model experiments what the world in which we live, not the world in which we wish to see, would bring us in terms of impacts and what kind of governance mechanisms that might require us to think about if we ever imagine that this could be deployed. I mean, that's one piece. We need to have research. And my own personal view is that needs to include some small-scale outdoor experiments, not the provocative, non-scientific versions of them, like the Make Sunsets piece that that Oliver alluded to, which we could talk about if you'd like, but meaningful experiments, ones that can, on a very small scale, help us understand how to improve models by understanding how aerosol particles disperse and so on. But we also need informed consent about these experiments, because people look at them, and we've seen some experiments that have been shut down peremptorily because people, who might ultimately benefit from that knowledge have decided that they weren't asked in a meaningfully publicly engaged way what they thought about those experiments. We need a kind of process that allows a broader set of publics to be involved in decision making about experiments that are triggering of larger conversations about whether or not we should be taking solar geoengineering as a possible climate response seriously. We haven't had that public conversation. The kind of work that Suchi is doing in the Global South is really essential to begin to build that out. And the U.S. government, I'll just say one more piece, prompted by a National Academy report that Kate and I both wrote a couple of years ago, along with many other authors, is beginning to explore whether the U.S. should have a dedicated solar geoengineering federally funded research program. I think there are versions of that could be good if it's done in collaboration with other nations and has the right kind of governance of the research set in place. And there are versions of that could be done quite poorly. And we could talk about some of those dimensions. I guess the last thing I'd say is that taking solar geoengineering seriously means taking decarbonization really seriously, of trying to limit the extent to which we might be provoked into taking this kind of, again, terrible response that may ultimately become inevitable. And, just today, the Biden administration is set to announce the approval of the Willow Project, some of you may know about, on North Slope of Alaska, which is a major new investment in oil exploration through ConocoPhillips that's producing enough oil to cause carbon pollution equivalent to 2 million cars on the road, gas-powered cars on the additional 2 million cars on the road every year for the next 30 years. In my view, taking decarbonization seriously means actually moving towards mitigation at a scale and pace that we're not currently doing. And so we need a lot more commitment to mitigation in order to ensure that our kind of understanding of solar geoengineering is in the context of that primary response and primary climate solution, not having this kind of further reinforce the moral hazard concerns that so many legitimately have.
Yeah, thanks, Peter. I'd like to go back to the point about outdoor experiments for a minute, because like I said, almost all the research on solar geoengineering really has been done in computer models. And we know that these computer models in particular, don't actually get the details of how the climate system works right all the time. There's been a lot of concern, both in the scientific community as well as the science governance community, the policy community, about this idea of doing outdoor experiments, like it's somehow a step towards deployment. And there are absolutely valid concerns about that. Both Peter and Oliver brought up this idea of moral hazard or mitigation deterrence associated with thinking about this topic. There's also this concern about a slippery slope, which is this idea that once you get people invested in these activities, their deployment becomes inevitable because interests build up around seeing that happen. The thing is, though, that outdoor experiments don't necessarily mean that support for geoengineering is going to grow or that it's going to look better. I think it's much more likely that we find out a reason that we can't do geoengineering, that it won't work, or that it's a really bad idea once we start doing these outdoor experiments. And I think we see evidence for that from what happened with another one of these proposals that I talked about at the beginning, called ocean iron fertilization. Now, there was a big boom actually in ocean iron fertilization about 25 years ago. And this is because it was very robust evidence from the science that adding iron to certain parts of the ocean causes phytoplankton blooms. And so as people were getting really concerned, we weren't taking climate change seriously enough, there were a bunch of scientists and startups as well that got excited about ocean iron fertilization. And they actually did go out and start doing experiments. And what they found through these experiments, a series, there was more than a dozen of them, that they found that the theory was right, that you could cause phytoplankton blooms by adding iron. The problem they found through doing observations is that most of the time, those phytoplankton blooms don't result in the sequestration of carbon. That carbon that you've produced doesn't make it out of the mixed layer of the ocean, which means that eventually the carbon dioxide just gets released back into the atmosphere. So by doing those experiments, we found out, ocean iron fertilization is not going to save us after all. And that was a really important moment in changing the focus of how our research about managing climate risk evolved. I guess the other thing I'd say just about climate science in general is that when we think about the information we have about climate risk management and climate risk decision making, if you think about every other area of approaches we have to managing climate risk, mitigation, even adaptation, the amount of information we have about these other approaches just dwarfs what we know about solar geoengineering. There are thousands of studies about what the agricultural impacts of climate change will be, what the agricultural yield benefits of reducing CO2 in the atmosphere are. And we have like 5 studies, maybe, about how solar geoengineering might affect these things. In the presence of such a imbalance of information about these things, you absolutely just can't make good decisions about risk and how to manage it. And in those cases, people project their hopes sometimes onto what might happen. And that makes right now, I think, a very dangerous moment for solar geoengineering research. And so we really, I try and tell my colleagues, you really need to get involved here and do what you can, because the impact you can have with your climate science in this area is just massive.
The fact that you have to tell your colleagues that, why do they resist it?
Because despite how things are changing a bit, solar geoengineering is still a very controversial topic. Climate scientists think about solar geoengineering, the idea of trying to counteract greenhouse gases by reflecting sunlight. They think about it, they understand how complex the climate system is, and they say, wow, that's a terrible idea. And they're right, it is a terrible idea. But again, I think sometimes climate scientists among everyone, they sometimes make assumptions about how much agency they're actually going to have in these decisions. And the fact of the matter is, with the incentives, the low direct costs, the very quick timelines for a climate response, the incentives are all there, the lack of governance, such that this might happen whether it's a bad idea or not. And that's why having this information to make a legitimate response is so important.
Yeah.
Yeah, no, just to build off of that and a little bit off of your previous question around what taking solar geoengineering seriously means. To me, taking solar geoengineering seriously means that we're actually taking human suffering seriously, which I don't think we are right now. In terms of the climate impacts we're seeing, the climate impacts that are already baked into the system, that will come, that will largely affect the global south, we are not talking about them. When we look at huge legislation that has passed in the United States in the last 2 years, it's incredible. But is there a deep focus on climate impacts? Is there massive funding for climate resilience, even in the United States? And the answer is no, there's not. And so when we think about solar geoengineering and the climate impacts that will come, and the fact that we're not really funding loss and damage, that we're not funding adaptation, solar geoengineering starts to become a much more political likelihood. And even if we were to fund loss and damage, money does not compensate for the suffering that will happen. And I think this is a really important point that I think when we talk about solar geoengineering, especially over the last 20 years, it's been incredibly difficult to get people to take it seriously from a political perspective. But we're not thinking about how other people are experiencing climate change right now. And as we even kind of move through kind of thinking about how we might build more effective systems to govern solar geoengineering, the Global South is largely absent from those conversations too. And so if we build systems to govern solar geoengineering from the same places that created a lot of the climate crisis in the first place, legitimacy in this space is going to continue to be more and more challenging. And so, to build off of what Kate was saying, agency is so critical here. There is no agency across, the massively heterogeneous regions in the Global South. And so one thing that I think is going to be really critical here is knowledge, and building more knowledge and providing resources to build that knowledge in so many more places. I think, one of the reasons I think we're not seeing as much research, we're not seeing as much participation in this space is because people don't even know it exists. That's true in the United States, that's true across the global north, and it's especially true in the global south. And so I think we have to start thinking really thoughtfully about how to build that knowledge, what kind of knowledge, in what ways we're building it, and how we actually politically empower it.
I wanted to follow up on something that Peter said, and then I'm going to come to you for questions. But specifically with you on that subject, Peter said that you could imagine a good American solar geoengineering research program or a bad one. For you, if the U.S. federal government were to develop a robust national geoengineering program that didn't have a big international component, would that be a bad one?
I think that would be a colonialistic failure, to be quite honest. I think moving unilaterally from, in the United States would be a huge mistake. I think if we, continue to lean on the systems that have continued to lift up colonialism around the world, we're going to see continued problems around how solar geoengineering is built. And that's not to say I don't support a public research program in the United States, but I think it has to be built extremely carefully and with so much participation, both domestically and internationally. And I think, when we think about research, oftentimes it's limited to academia. But, I think something that's going to be really important is thinking about how we build research questions, right? I think right now, because the research community is largely based on the global north, we don't have the expertise that, across the global south from, input from how they understand their regional systems, how weather patterns have changed over time in those spaces, how different sectors have responded to different climate and weather impacts in the past. That will be critical to understanding the regional impacts of solar geoengineering. And so both from a justice and ethics perspective of having that input, but from a deeply substantive perspective of building a system that will have more benefits for more people.
Great. Now, we have a microphone. We have lots of interested people. Let us put them together in a reasonably both careful but quick way to try and get some questions. Please.
Okay, hi. I wrote a paper on geoengineering in 2008 at UEA, so I'm somewhat relieved by the lack of progress in this field. But the point that I realized 15 years ago was that if one group of actors can deliberately modify the climate, it means another group of actors can also modify the climate almost to counteract that. And undeniably, there are some countries in this world that benefit greatly from global warming. The permafrosts are 3 times larger than the surface area of the United States, and the planet is running out of farmland. The global south is suffering from droughts. We are running out of land to grow crops, and potentially the permafrost in Russia, Canada, Alaska can actually allow humanity to keep growing crops. So if we do run out of food space, surely one country can then start to re-warm the planet again, counteracting the cooling which other places have done, and then you've got geoengineering wars taking place. So I'm interested to hear your thoughts on that prospect.
Okay, I'm going to take some more questions before we come back to that.
Hi, thanks very much. Two questions. Firstly, the one that really struck me was Kate's comment, because I've been kind of thinking, I don't need to worry about this too much because it's surely way too difficult and expensive. And your comment was actually, no, it's enormously incentivized because it's cheap and quick and quite easy to do, it seemed, and doesn't appear to have a lot of obstacles. I'd love you to enlarge a bit on that, because to me that would be scary. If it was cheap and easy, so many things about mitigation are difficult and have obstacles. And the second question was probably more for Shuhi, and excuse me mangling the name, are there any examples of kind of global governance? I mean, I have a sense that we have some kind of rules about how space is used and stuff, maybe not, or the oceans or something. Are there any examples of global kind of beyond COP and climate, how it might work? Thanks.
I'll take one more.
Ken Bissler, oceanographer at Woods Hole. I guess my question will be about messaging, how we do a better job of messaging really complex issues, because the example today, I was on the boat when we added the iron, and we added 1 ton of iron and got 4,000 tons of carbon sequestered in that experiment. Now, I also wrote the paper, Will It Work? Because that's not enough. That's about as much as the largest direct air capture plant gets out of Iceland today. So, in fact, we had made progress, but then it wasn't put forward in the right way in terms of our ability to solve a climate crisis. So I think I'd like comments on how we do a better job of messaging these complex things when there's more than one way to look at the results, apparently.
Okay, I'm going to disappoint everyone by also pointing out that, yes, we will discuss how to message complex things within the next 9 minutes. So going back on those, I'm actually going to take one of them, but we had the question about different countries wanting different things, some wanting more warming, some wanting less warming. I'd love to hear from anyone on that. And also this question that I don't think we really got into, maybe Kate could speak to, about the degree to which things are cheap and easy. But I wanted to come to the question about, is there any successful global governance at all? And one of the things that we didn't bother to put onto our slide of different methods is the idea of intercepting sunlight before it comes to the Earth with mirrors in space. And this is not a practical first-generation solar geoengineering option. But when I was at a meeting on this a couple of years ago, I realized that one thing that would be wonderful about that is that, as you say, we do actually have an international governance process for space that says that if you do stuff in space, it has to be for the benefit of all mankind. And it does actually say mankind, but you know what it means. And that would be the one advantage of space-based solar geoengineering. There is already a governance structure saying, if you do this, you have to look after everybody. There's nothing like that anywhere else. And I don't think that in itself is going to lead us to space mirrors. But anyway.
Can I add one more?
Yeah.
Just one more success story that I think has some applications to this space too, is the Montreal Protocol. Which is probably the most successful environmental treaty in history, where we actually successfully were able to reduce ozone-depleting substances in the stratosphere, which has kind of a direct relationship to stratospheric aerosol injection. But I think the interesting thing about the Montreal Protocol is that there was financial incentive to actually make it happen.
Yeah.
There were companies that were wanting this to move forward because they had a profit motivation behind it. And I also think the political processes behind it and developing countries participating in it and able to get outcomes that they wanted was actually quite challenging in the building of the Montreal Protocol. So I think it is a successful global governance system, but it isn't perfect. And I think the challenging thing about solar geoengineering is that it is probably one of the hardest things that we're going to encounter to try and govern.
I want to build on that
Yeah.
if I could. I totally agree with the success of the Montreal Protocol. It is a very different set of issues we're trying to address, especially
Absolutely,
over
yeah.
the period of time, indefinitely long, under a range of assumptions that levels of solar geoengineering and decisions about deployment would need to be made. So I totally agree it's a really important precedent, but it's also imperfect, obviously, relative to the challenge that we're facing here. There's also a lot of governance around research of risky technologies that I think is worth just acknowledging. And governance can be both enabling, it also can be restricting. We need both in this space. But on the restricting side, we have in 1963, nations got together and decided to set a ban on atmospheric tests of nuclear weapons, right? There's a nuclear non-proliferation treaty. There are bans on chemical weapons research. There are not global governance dimensions, but lots of global conversations about restrictions on human germline genome research and its applications. So, we probably need, in my view, as we build towards small scale, really meaningfully small scale outdoor experiments, also some kind of restriction on large scale experiments. Because once you get to the level where you're actually perturbing the climate and getting a climate response, you're essentially doing deployment. And we don't have at the moment any governance around research at any scale in the atmosphere, and we need on solar geoengineering. And we may need to both enable some, in my view, and restrict others. And that's a conversation that really hasn't yet been fully joined.
I think it's worth pointing out that some of the Biological Warfare Treaty, the NPT, it can be useful to have an imperfect governance system. There has been proliferation under the NPT. There's been less than you would expect otherwise. But I was interested in pulling that together with one of the other questions. How important was the messaging around the ozone hole and it seems to me that in terms of sort of like a scientific finding that really did trigger a large response, that's a very key example, wouldn't you say?
No, I totally agree. And I think it was extremely effective in terms of a global unifying fear, which I think is less so in terms of climate, right? I think the global north is going to see less climate impacts. And I think that's one of the reasons why it's been much harder to move the space forward in directions that I think it needs to move in. One thing I do want to add, though, is that there is some research governance right now in solar geoengineering. It's ad hoc, it's not formal, but so there has been a proposed outdoor experiment by a research team at Harvard, and they've created an independent advisory committee to oversee that experiment. I'm a co-chair of that committee, and we have put forth guidance on how we think this research team should proceed around local public engagement, around scientific merit, around legal and financial transparency. And these things exist now. And I think the problem, though, is that it's not enforceable to other experiments or to other actions in this space, right? For example, I think like for Make Sunsets, they didn't follow any of this guidance that does publicly exist, right? And there are no consequences to them not following that guidance. And so there is research governance, but it is not formalized, and there are no consequences to not adhering to it.
Okay. Is it a success or a failure that after 10 years of discussion that Harvard experiment has not flown?
I think it's a mixed question, right? Because I think the existence of the advisory committee, in my opinion, has not slowed down the experiment per se. I think controversy has slowed down the experiment. And I think scientific research and the normal processes of working through issues and engineering issues has slowed down the experiment. And so I think there are pieces of governance that could have helped ScopeX move faster. And there are pieces that have been more challenging for us to move through, like understanding how and when to apply public engagement, I think is a really open question that we don't have a lot of certainty around. But there are things like scientific merit and transparency that are very easy to apply that we're just not.
Kate, the point about how easy this is to do and what one might mean by easy.
Right. So, there's this sort of oft-repeated phrase about solar geoengineering, that it's cheap, fast, and imperfect, right? And the cheap and the fast, I think, is what sort of leads to the conclusion of easy. In terms of the direct costs of doing stratospheric geoengineering, if it works, they look like it would be, several orders of magnitude smaller than decarbonization for the same global cooling effect. I think really the main thing about solar geoengineering that makes it almost inevitable under some circumstances, especially a continued lack of governance, is actually the fast part, though. Because compared to every other way we have of managing climate risk, this time scale of 1 to 2 years for a major cooling effect is just so much faster than anything else that's out there. And in the context of disruptive climate change, that's the only thing that works on political timescales, right? Which combined with these low direct costs sets up these incentives, right? But this is another reason why I do think finding a governance system and a path forward for doing these small outdoor experiments is so important, because once we start trying to do this in the real world with real hardware, observing the effects, it's just completely plausible that it won't be nearly as easy as we think it's going to be.
And that's basically the place I think we're going to have to leave it, given the time. Sorry we didn't get to the point about different countries wanting different things, but in a sense, that underlies almost all of what we've been saying. What if someone else tries to do this? What's your sort of response? Thanks for being a terrific audience. Thanks for being engaged. And thank you to the panel.